Students, good morning. This is Dharmendra Goyal, 25 years teaching experience, ex-faculty FITG for your IIT Advanced 2026. Every day I am going to upload one important questions which is very important for your IIT Advanced. हम ये क्वेश्चंस एरोडो पाथफाइंडर एज वेल एज खुद के फ्रेम के क्वेश्चंस के रेफरेंस में डिस्कस कर रहे हैं. सो in this question student, this is taken from Pathfinder, question number 10, chapter 3, that is work and energy chapter. In this diagram students, there is a ball of mass 5 kg. This ball or this is block of mass 5 kg is suspended in a box of mass 20 kg, and the whole system is placed on horizontal floor as shown in figure. What is maximum amplitude can the block or ball oscillate up and down so that box just lift the contact with floor? So this is the question students. Once again repeating. See student, in these questions, this block of mass m, as you know, in SHM chapter students, suppose there is a spring, a with block, that is a spring mass system. The free end of the string, this free end of the spring, when it is unstretched, is taken as a reference line. I think you know it. Why this is called reference line students? Because reference to these positions you measure extension, compression of the spring. And there is another line that is known as equilibrium line. And how you get this equilibrium positions? Suppose this position is x0. So for getting equilibrium positions, you put summation force acting on ball should be 0. Students, if you release this ball or block slowly, it will stop at equilibrium positions, right students? And this equilibrium positions, by using these equations, mg is equal to kx naught, and this x naught is equal to mg, m is given 5 kg, g is 10 divided by 500, that comes to 50 by 500, 1 by 10 meter, that is equal to 10 centimeter. So 10 centimeter is their equilibrium positions. But question is what students? What is their amplitude of vibration? Suppose without hold, if you release it, then it will move further 10 centimeter and stop, return back to equilibrium positions and goes to reference line. But students, if you think it about, it just oscillate 10 centimeter above from the equilibrium position, 10 centimeter below the equilibrium positions. So in these conditions, whether this box will uplifted from this table, क्या ये box table से uplift हो सकते हैं? So first you should think about the demand of the questions. This question is asking what should be the amplitude of oscillations so that this box just uplift from this table. Uplift means students, you have to put n is equal to 0. See, n is equal to 0, although box having weight, how much weight? That is 20 into g, that is 200 Newton. Until and unless someone pull it up by applying a force of 200 Newton, this box could not lift their contact, or n, the value of n cannot be 0. जब तक कि आप इसमें फोर्स ऊपर नहीं लगाते हो, नॉर्मल फोर्स का वैल्यू बॉक्स और टेबल के बीच में 0 नहीं हो सकते. क्लियर स्टूडेंट? इट मीन्स या तो आप आइदर यू पुल इट अप, होल बॉक्स को ऊपर उठाएं, या समवन इज पुशिंग बॉक्स इन अपवर्ड डायरेक्शंस. सो if it oscillates only 10 centimeter, then a spring comes to this position, that is the reference line, and in this position a spring is not compressed. So for this a spring should be compressed, and if a spring should be compressed, it means it will move above the reference line by some distance, and if a spring moves above this reference line, it means a spring get compressed. And जब ये स्प्रिंग कंप्रेस होंगे, कंप्रेस स्प्रिंग विल exert force on box in upward direction. Right, students? So this is the key of these questions, right, students? So you should find out how much compressions in this spring so that normal force will be 0, right, students? So to solve these questions, what to do now, students? अब हमें क्या करनी चाहिए? सबसे पहले we should draw the force body diagram of this box when it lifts the contact. This is your table. The spring force exert force in upward directions due to compression of a spring. Suppose this is the reference line, so it should compress the spring. And if it compresses the spring, that means a spring exerting external force, acts as external force over this box. So suppose compression length is equal to kx, and it should balance their weight. Weight is equal to 20 into g. That comes to compression length is equal to this box is 20 kg into g means 200 divided by 500. If you solve it, it comes to 2 by 5. 2 by 5 means this comes to 40 centimeter. So compression in a spring should be 40 centimeter, right, students? So now how you get amplitude of vibrations? So see, students, once again the whole questions. This is your ceiling of the box. From here, this is the spring. Suppose this is the reference line, and next point is this is showing their equilibrium positions. Already I have calculated equilibrium positions, 10 centimeter, right, students? If we not pull it or simply we release it, and if it moves under the gravity, then it will move from equilibrium positions 10 centimeter below it and return back to these positions, and it will never compress. It means to uplift this box, it should move 40 centimeter above from this reference line so that a spring get compress, and compressor spring just uplift the box from the table. So this comes to 40 centimeter and this comes to 10 centimeter. So how much this length, students, from the equilibrium positions? 40 plus 10, 50 centimeter. It means reference to equilibrium line, it moves 50 centimeter above and 50 centimeter below. So what is answer, students? Answer is 40 plus 10, 50 centimeter, and in general form, amplitude which is measured from the equilibrium positions is equal to m plus capital M into g divided by k. This is your answer. Students, in these questions आप इसमें कुछ और भी चीजें सोच सकते हैं. What is maximum value of normal force? When this normal contact force in between the box and the table becomes maximum. Suppose, students, there is no oscillations. Then how much total weight? 5 kg plus 20, 25 kg multiplied with t, that is multiplied with g, that is 250 Newton. But when it start oscillate and it goes from equilibrium positions 50 centimeter below. So when it comes to these positions, the box experience maximum normal force. So how you calculate maximum normal force, students? So how much a spring will expand from this line? You think it this moves 50 centimeter above, from equilibrium it's moved 50 centimeter below, but total extension when it expand maximum, total extension in a spring is 10 reference to this line. This is the natural line. 10 plus 50, that is 60 centimeter. So in that condition, students, the normal contact force at the base of the box, if this is the box, a reference to this line, when it moves 60 centimeter, means equilibrium, it's moved 50 centimeter. So a spring force is corresponding to 60 centimeter extension. Do not consider their weight of this hanging mass, because over the box the force acting by this block is not directly, rather than by the spring. So when a spring expands by 60 centimeter force means K into 60 centimeter, 0.6 plus weight of the box. What is weight of the box? Mass of the box is how much? 20 into 10. So this is the maximum normal force. K is given 500 plus 0.60 and plus 200. That comes to 500. If you calculate it, this decimal, that is the 500. Okay, thank you students. And next day I will discuss some another questions. And one more thing students, आप में जो भी स्टूडेंट्स को डाउट क्लियर करना हो, बिकॉज मेनी रिसोर्सेस आर देयर, मेनी कोचिंग इंस्टीट्यूट्स आर देयर, सो दोज स्टूडेंट्स हु आर इंटरेस्टेड फॉर डाउट, सो ऑनलाइन मोड आप इवनिंग में आफ्टर 8:30 आई विल गिव यू टाइम विथ ए नॉमिनल चार्ज पर आवर, इट इज ए कॉस्ट ऑफ 1000 रुपीज़. आप हमारे ऑनलाइन क्लासेस ज्वाइन कर सकते हैं. मैं 2-3 क्लासेस आपको फ्री ऑफ कॉस्ट में दूँगा. आपके IIT एडवांस के जो भी क्वेश्चंस होंगे आप एक दिन पहले मुझे मेरे व्हाट्सएप में आप भेज देंगे. आई विल डिस्कस इन नेक्स्ट डे. आप हमारे व्हाट्सएप नंबर नोट कर लीजिए 6264007784. और स्टूडेंट्स, मैंने अपने 25 सालों में बहुत अच्छे रैंक प्रोड्यूस किया हूँ. 2010-11 में मैंने विपुल सिंह फिर भिलाई सेंटर में 5th रैंक प्रोड्यूस किया हूँ. बहुत सारे रैंक हमने प्रोड्यूस किया स्टूडेंट्स. सो दोज हु आर इंटरेस्टेड फॉर डाउट क्लियरेंस, आप इसमें आप में व्हाट्सअप करें, आप क्वेश्चंस भेजें. आप 1-2 क्लास ट्रायल ले सकते हैं, फिर आप रेगुलर बेसिस पर आप उस टाइम को बुक करेंगे तो मैं आपके लिए अवेलेबल रहूँगा. थैंक यू स्टूडेंट्स.